Hi students, I'm back for lesson 92, the second example. We're talking about boats in the river problem, and last time I did example 92.1. This time I want to do example 92.2, and it's on page 383 in my book. And I'll read it to you, and you can follow along if you like. The steamboat Juby Fountain could go 70 miles downstream in 5 hours, but required 6 hours to go 48 miles upstream. What was the speed of the boat in still water, and what was the speed of the current? Okay, so this time we're being given 4 of our 6 variables, just like always. This time we're getting the 2 distances and the 2 times, and we have to figure out the 2 speeds. So let's start by picking up our the equations that we need to use. Our downstream equation. The boat is flowing with the water when it's going downstream, so we add the boat plus the water times the time downstream. Remember, this is equivalent to the rate. It's just that our rate is complicated. Downstream, we add the 2 to equal the distance downstream. When we're going upstream, that's when the boat is fighting the current, so it's the boat minus the water times the time upstream equals the distance upstream. That's the part to memorize, right? Okay, so with those equations, we make a simple list of our variables. John Saxon skips this step in his layout of each problem. I don't like to skip it because to me it's a very clear process. Identify your formula, plug in your variables, then substitute them into the equations. I don't like to skip showing you this. Okay, so let's go back. Our steamboat could go 70 miles downstream, so our distance downstream is 70, in 5 hours. Our time downstream is 5, but required 6 hours to go 48 miles upstream. So upstream is 6, and upstream is 48. All right, what was the speed of the boat in still water, and what was the speed of the current? So we need to solve for those two. Okay, perfect. So let's substitute in. I'm already running out of room. I'll do downstream over here. It'll be, so this will be downstream. Boat plus water, those are the 2 we don't know, times the time downstream is 5, equals 70. And then our upstream equation, I'm going to slide this up a little bit so you can see. Our upstream equation is boat minus water, our 2 unknowns, times the time upstream is 6, equals 48. All right, let's distribute out and see what we've got. 5b plus 5w equals 70, and 6b minus 6w equals 48. So now let's look at our 2 equations next to each other, and we have a system of equations here that we want to solve. And now it's a question of what strategy do we want to use. I don't see any terms that are automatically going to substitute out. I always compare the waters because there's a plus and a minus there, but our numbers are not lining up, so we're going to have to do some adjusting, aren't we? So what I'm going to do is I'm going to multiply this side by 6 and this side by 5, because our lowest common denominator, or our least common multiple is 30, right? 5 times 6. So I'll multiply each one by the other factor. I don't have to mess with the sign because my my waters will automatically cancel out. So if I just adjust the numbers, I should be fine. So now I will do that, and I have to remember to multiply 3 times. So I get 30, I'm going to write them in the middle now, 30b plus 30w equals 420. Okay, so that's this line. And then I'll do this one underneath, 30b, whoops, minus 30w equals 5 times 48, 40, 5 times 4 is 20, 24. Okay, so this is 240. All right, now I can combine these. 60b, these cancel, yay, just as I wanted, and this is 660. Oh, that's looking pretty good, isn't it? Let me just rip this page off. And line it up like this so we can continue to work. All right, so I'm going to divide both sides by 60. B equals, I can see right away that's going to be 11. So the speed of the boat is 11 miles per hour, even though I'm here in the rest of the world where they don't use miles. Technically they use kilometers. Everybody knows what a mile is. American influence is amazing. And then we substitute this back into one of our original equations, and I'm going to choose the downstream equation because it's got the addition. I'd rather avoid subtraction whenever I can. So now we have 11 plus W times 5 equals 70. See, I just substituted in the B right there. And then I have 55 plus 5W equals 70. Subtract the 55. That goes 5W equals 15. So the speed of the water equals 3 miles per hour. Boom! Problem solved. Okay, you guys try 92.3 on your own and see what you can do. Feel smart, you guys. These are really complex problems, and I'm really proud of you for diving into these, boat and river driving, and making sense of them. Good job.